Now let's go ahead and talk about how we can find the mean and the standard deviation for a geometric distribution. Like we saw with the binomial distribution, since there were some interesting patterns that we were able to kind of bundle together and call the binomial distribution, we ended up finding nice easy patterns for the mean and the standard deviation, and we're able to create formulas. And the same thing's happening here with the geometric. So notice here that I have in my box a formula for how I can compute the average value of x and the standard deviation for x. These formulas are also presented right here on the formula sheet. Notice that I don't ever really have to produce these values unless I'm explicitly asked to. So I would highly advise don't do them on every problem because you're really just going to be wasting time. However, in this question, we are going to be specifically asked for them, and so we'll try to go ahead and compute them. Let's see, part F. How many attempts at the slot machine should we, here we are again, how many attempts should we expect to have to make before we win our first reward? So I'm looking for the average x. That's, notice the same x I had up here, the average number of plays it takes to earn a first jackpot. And that's exactly what we're being asked here. So this apparently is easily calculated as just 1 over p, which in this case is just 1 over 0.15. Now if I calculate that in my calculator, you should be able to come up with a final answer of 6.6667, and that I guess would be attempts or plays or pushes of the button, pulls of the lever, however you imagine that slot machine. So we would expect to have to pull the lever, 6, almost 7 times before we get that jackpot, which is pretty good. Casinos do not have usually a success rate of like 15%. That's way too high. Okay, so now what about the standard deviation? The standard deviation formula is a little bit scarier, but it's not really any more complicated. Now if I take a look here, this is just going to say that I need to do 15% being squared down here at the bottom, and then on the top of the fraction I'm going to do 1 minus p, or 1 minus the 15%. Notice in this case that would get me 85% up there, right? 0.85. And now if I was to crunch all this out in the calculator, I could get let me rewrite that. I have 6.1464 attempts. And you could double check that yourself using your own calculator to finish that square root. So again, we should be able to interpret what this value means, right? We would expect to have to pull the lever 6.667 times. However, don't be too surprised. It's not uncommon to have to pull it somewhere between this many more or this many less attempts from average. So I'll write it like this. It is typical to need between 6.1464 attempts above or below the average of 6.6667 attempts to win our first reward. So again, calculating means and standard deviations should be very, very simple. I have to make sure, though, that I'm using the appropriate formulas based on the appropriate distribution. So since here I'm working again with the idea of how long do I have to do something to get my first reward, that's definitely geometric, and so I'm using these geometric formulas.